Hello everyone, welcome to the channel Understanding.Concepts.Of.Physics. Here we are with another video on waves. Today we are going to discuss with certain key points to be noted in order to understand waves better. So the first and foremost point, as you can see on the screen, when a wave travels from a rarer medium to a denser medium, the phase change is pi radians, and when a wave travels from denser medium to a rarer medium, the wave phase change is 0 radians. So this is what it is. You should be remembering that how a wave, when it's traveling from one medium to another medium, let's say suppose if this is that wave which is traveling from one medium to another medium. Now as it strikes this point, now it is going to come back as a draw. So this would be a draw, and then again it will keep on coming back. So here we get a stationary wave. Now this stationary wave, if you see, there is a crest over here, and while returning there is a draw. So this was a crest and this is a draw. And when you have a crest and when you have a draw, the phase difference between a crest and a draw is equal to 180 degrees, or we also call as pi radians. This I have explained to you in a very detail how to find out the phase differences in chapter called oscillations. So I would like to say that just go back to the playlist and find oscillations playlist, and you can just get how this pi radian comes. So the people who have followed that, they have understood. In case if you have not followed it, if you have not been with me in these previous videos, then you can always check, or you can just remember that when a wave travels from a rarer medium to a denser medium, you always get pi radians. And when the wave travels from a denser medium to a rarer medium, the phase change is 0 radians. So like if suppose there is this rod and there is some ring which is attached to a rope or a string, and when this vibrates, a crest will be reflected as a crest, something like this. This is while going and this is while coming. So if you send a wave something like this, after a certain point, after traveling this side, you will find out that the ring actually travels upwards, and then it is going to travel downwards as well, but the wave is going to travel this way. So after a certain point, you will find out that the wave goes ahead. Now, so if a crest is reflected as a crest, then the phase change is not there. That means it's a 0 degree, is a 0 degree or a 0 radian change. So what we can conclude here is, if a wave travels from a rarer medium to a denser medium, and if a wave travels from a denser medium to a rarer medium, then we call that phase difference from rarer to denser, it is pi radians, and from denser to rarer, it is 0 radians. So either you can remember it like this, or you can just remember it in words. When a wave travels from rarer to denser, the phase change is pi radians, and when the wave travels from denser to rarer, the phase change is 0 radians. The next point to be noted is regarding nodes. Now there are this is a new terminology which I am using for the first time, that is nodes. It is also called as displacement nodes, and it is also called as pressure antinodes. So remember that it's nodes and it's nodes, but here it is an antinode. So nodes, displacement nodes, and pressure antinodes all are one and the same thing. What is this? The points in the medium which vibrate with minimum amplitude or zero amplitude are called as nodes or displacement nodes or pressure antinodes. And the points of the medium which vibrate with maximum amplitude are called as antinodes, displacement antinodes, and pressure nodes. So I hope you might have followed this up. See, this is nodes, this is antinodes, this is displacement nodes, this is displacement antinodes, this is pressure antinodes, this is pressure nodes. Note that antinodes, displacement antinodes, and this is a pressure node. So there is something similar and something dissimilar. So if you just identify the key points where things are different, you can just recreate your definition. So the points of the medium which vibrate with minimum amplitude are called as nodes, and the points of the medium which vibrate with maximum amplitude are called as antinodes. So nodes and antinodes are basically opposite of each other. So whenever the displacement is maximum, we call this as when the displacement is minimum, we call this nodes. And at that point where the displacement is minimum, the pressure is the change in pressure. The change in pressure is maximum. So here the displacement is minimum, but the change in pressure is maximum. And here the displacement is maximum, but the change in pressure is minimum. That's why it is called as these two stuff. I'll just show you what it is. So if this is my stationary wave, which is traveling in this direction. The magenta line, magenta wave is something which is traveling in the positive side, and the orange colored line is traveling in the negative direction. Now I have just vibrated one end of the string, and this wave is actually traveling like this, and it is going to get reflected. So let's say if the magenta line is going forward, then if it is hitting a rigid boundary, it is going to reverse in a draw. So a crest will be reflected as a draw, and then it will keep on moving like this. Okay, so a distance between a crest and another crest of the same wave is what is called as wavelength. So that's what lambda is. Now in a stationary wave, the things appears to be stationary. That's the reason why this point, this particle is moving up and down, this particle is moving up and down, this particle is so and so on. So these points are what are called as antinodes. Why? Because they have the maximum displacement, but here the pressures are minimum. So that's why it is called as pressure nodes. Okay, so these are called as antinodes. That's why I have represented them with a A. Can you see now? So this is A, antinode, 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 and antinode. So these points are basically called as antinodes. And wherever these points which I am just marking right now, these points are not vibrating at all. They are not moving up and down. They are not moving up and down. They are just stationary. They are not moving up and down. That means these particles have zero displacement. So these particles are called as nodes, 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 and nodes. This can also be called as displacement nodes, and they can also be called as pressure antinodes. So now why is this called as pressure antinodes? Because the pressure at these points are maximum. Okay, so like if you have if you have this as a rope, and if you are vibrating from one end, you will experience that this end is going to have the maximum jerk or the maximum change in pressure. Same these points as well. Okay, but if you are holding it at these points, you will find out that the change in pressure is minimum. Okay, so these are what these things are. So just to conclude, at nodes displacement is maximum. Oh, I just made an error over here. At nodes the displacement is minimum, so this should be minimum. Okay, so at nodes the displacement is minimum, however the change in pressure is maximum. Okay, and antinodes, and at antinodes the displacement is maximum, however the change in pressure is minimum. So now this is correct. Okay, and the last point for today is the boundary condition. The boundary condition says there is always a node formed. Remember that there is always a node formed at the fixed end, and there is always an antinode formed at the free end. So nodes at the fixed end, antinode at the free end. Now why I am saying that way? The reason is, if you see this wave, this is a string or a rope on which these waves are traveling. Now can anyone tell me, can you just think of yourself that, okay, will this point, if this is stuck very tightly, if this is not moving, then this is a fixed end, and if this is fixed, this point is not going to move up and down. This point is not going to move up and down. That means this point is fixed. This point is fixed means this point has a zero displacement, and the points which have zero displacement is called as nodes. So that's why the fixed end is always a node, and the free end, if you see, this is the free end, this can vibrate. You are actually vibrating over from here, like you are just moving your hand up and down from here like this. So because this is a free end, this is going to have an antinode formed always. So at the free end, at a fixed end, there is a node formed, and the free end there is always an antinode formed. So this is what the boundary condition is. So with this, we have made ourselves equipped with all the terms and terminologies, and from the next video onwards we can actually delve into the actual derivations of equations of stationary waves. So hope you have enjoyed this video and you have got something to learn from this. Thank you so much for watching. Subscribe the channel in case you have not done so, and keep watching the videos from the full playlist. Thank you so much. Have a nice day. Bye.